Good morning. Today I'm going to use the Casio's fx-570EX Classwiz calculator. Finds the smallest magnitude. Finds the smallest magnitude eigenvalue using inverse Hall method in the matrix manual. Let A be an n by n matrix, and eigenvalue of A are eigenvalue of A. If we have n by n, then we have n eigenvalue such that let's label as lambda 1, lambda 2 up to lambda n, such that magnitude of lambda 1 is greater than magnitude lambda 2, greater than magnitude lambda n. In this case, lambda 1 is a dominant or the largest magnitude eigenvalue, and lambda n is the smallest magnitude eigenvalue. By using inverse metric method, the eigenvalue of the inverse metric method, this eigenvalue of A, eigenvalue of the inverse metric method will be equal to 1 over lambda 1. For the first eigenvalue will become 1 over lambda 1, the second 1 over lambda 2, and for the last eigenvalue will become 1 over lambda n. Such that because lambda 1 is initially lambda 1 is the largest magnitude, so so when we 1 over the largest will become the smallest. Initially lambda n is the smallest magnitude, so when you have 1 over the smallest, so 1 over lambda n will become the largest magnitude. So now 1 over lambda n, because initially lambda n is smallest, 1 divided the smallest will get the largest magnitude of the matrix A inverse. Let's denote the largest magnitude eigenvalue of A inverse by lambda inverse. Because if we use a power method, on matrix A, when you apply power method, you will get the largest, eigenvalue, which is lambda 1. If you apply power method on matrix A, so you get largest lambda 1. If you apply power method on the A inverse, again we'll get the largest eigenvalue. Let's denote as lambda inverse. And the lambda inverse is actually equal to 1 over lambda inverse is equal to 1 over lambda n. When you apply power method of matrix A, you get the largest magnitude eigenvector is lambda 1. When you apply power method on the A inverse, we get the largest eigenvalue. Let's denote as lambda inverse. So the lambda inverse is the largest magnitude, which is equal to 1 over lambda n. Hence, the lambda n is the smallest, right? So the smallest eigenvalue will be equal to 1 over lambda inverse. Then how to get the lambda inverse by power method? So to get the lambda inverse by power method, we need the A inverse. Later on we need the initial eigenvector. When k equal to 0, we get the eigenvector at step number 1 is actually 1 over m1. A inverse and then initial eigenvector at step 0. So you get the first eigenvector. So what is m1? Similar, same with the power method. M1 is actually the largest magnitude of A inverse multiplied B naught of A inverse BK, because for this specific case, M1 is A inverse B naught. So if MK plus 1 will be A inverse multiplied BK, then we get the M1. So once A inverse B at the step 0 divided by M1, we get the first eigenvector. So the process is repeated. Until modulus of mk plus 1 minus mk less than a given epsilon, then the small from here, when you do the inverse power method on the inverse matrix A, you will get actually the largest eigenvalue, which is actually your lambda inverse. Lambda inverse is actually your mk plus 1, and lambda inverse is actually 1 over lambda n. So lambda n will be 1 over mk plus 1. Okay, and its corresponding eigenvector will be the same, which is vk plus 1 with the normal power methods. Okay, so I repeat one more time. Okay, the idea is actually you have a matrix A with the n eigenvector, whereas the lambda 1 is the largest magnitude, lambda n is the smallest magnitude. Okay, when we replace the A by A inverse, okay, then the eigenvalue of the A inverse will be 1 over lambda 1, 1 over lambda 2, 1 over lambda n. Okay, such that magnitude of 1 over lambda 1 will be less than 1 over lambda 2, less than 1 over lambda n. So 1 over lambda n is the smallest magnitude. Okay, sorry, it's a largest magnitude because lambda n is the smallest. 1 divides smallest. So 1 over lambda n is the largest magnitude. Okay. And 1 over lambda n is actually how we obtain it. We obtain it from doing power method on A inverse. We obtain 1 over lambda n, but we do the power method on A inverse, and we denote lambda inverse is actually our mk plus 1 and equal to 1 over lambda n. So in this case, you can find the lambda n is actually 1 over lambda inverse or actually 1 over mk plus 1. Okay, and its corresponding eigenvector will be v at step k plus 1. Okay, and this is a power method. Okay, the only difference is now matrix A is replaced by A inverse. Okay, so you have A inverse, okay, multiply V at step K, so M will be K plus 1. Okay, so you take A inverse, multiply VK, then from the A inverse multiply VK, determine the maximum magnitude, then that will be the MK plus 1, and then divide by MK plus 1, we get V at the next step. So the process is repeated, okay, until the modulus MK plus 1 minus MK less than epsilon, then the lambda n, which is actually 1 over MK plus 1, and its corresponding eigenvector is Vn equal to Vk plus 1. Okay, let's look at one example. Given the matrix A equal to 4, 3, 0, 3, 4, negative 1, 0, negative 1, and 4, use the inverse power method to find the smallest eigenvalue lambda 3. Because we got A is 3 by 3, so the smallest eigenvalue will be lambda 3, and its corresponding eigenvector V3 of the matrix A using the initial eigenvector V at step 0 is equal to 1, 1, 0 transpose, because eigenvector is suppose is 1, 1, 0. We turn it to row, that's why it's transpose. Stop the iteration until modulus mk plus 1 minus mk less than or equal to 0.005. We use 4 decimal place calculation. Okay, so first step, fill in the V node, okay, in our table. So this is V node 1, 1, 0. Okay, because this is Vk transpose. So K start from 0, so this is V node. And then you do the power method on A inverse. So do the geometric multiplication of A inverse times K. So take A multiplies the K the V nodes. So the result is here. Okay. So here we are in the matrix menu number 4. So first of all, we define the matrix A, which is 3 rows, 3 columns. Okay. First, in the previous video, we have do the power method to find the dominant eigenvalue. The matrix A is still in the memory. In the memory. This one is there already. Matrix A, because I inputted in the previous video, is still in the memory. Okay, if not, okay, so just input 4 equal, so 3 equal, 0 equal, 3 equal, 4 equal, negative 1 equal, 0 equal, negative 1 equal, 4 equal, because it's in the memory already. Okay, now what we want to find is the smallest eigenvector using the inverse method. So we need to find A inverse. A inverse. To do A inverse, so I put the A inverse in matrix. I think I keep into the A inverse as a matrix C. Okay. So I will keep my A inverse into the C. Okay. B, as in the previous video, I keep it as B. Okay, I keep it as a B. So matrix C. Put it as a matrix C. So C options. Define matrix. Okay, number 3, matrix C, 3 rows, 3 columns, okay, and then C, I'm going to keep the inverse matrix into the matrix C. Yeah? I want to do the inverse. So options, matrix calculation, options again. Okay, matrix A is number 3. Okay, I want to do the inverse. So this is a matrix answer. This is my matrix K inverse. Okay, matrix inverse of A. I don't want each time to do A inverse. I want to put this one into the C. Then C. Okay. So now, just now, what I did exactly, I find the inverse matrix, and then I press STO to, and then this button STO, and then I press X inverse. So now the matrix answer is stored in matrix C. So matrix C is my inverse. Okay, I have the A inverse. I keep in matrix C because I want to use vector V as a P. Okay, so now options. Okay, I want to see one, define matrix B. Okay, 3 rows, 1 column. Okay, already there 110 because the previous video I do find the dominant eigenvalue using the same matrix A and the same vector V where I keep as a B. Okay, so now my A inverse is stored in matrix C. Okay, vector B is stored in vector matrix B. I'm going to do the whole method where A inverse times V, where the A inverse, I will keep it as a C B. Then you do the A inverse V K in the calculator as matrix C multiply matrix B. Okay, now here. So now we are going to do take your matrix C multiply your matrix B. So options C multiply options matrix B. You get 667 0.0416. If you change it 0417. Done. And then the MK plus 1 is the largest magnitude of the A inverse B nodes. So from these three values, the largest magnitude. So it's 0.1667. Okay. And then now your V1. Okay, V at step 1 is actually your 1 over M1. Okay, K0, this is M1. This cell is M1 times A inverse B node. So you take the A inverse B node, which is okay in the next answer, divide by 0.1667. So this will be your next answer is actually your B. The vector B, so which is 0.4 7499 9998 or 0.25. So run a little bit. 7499 round it 75. This is 1. 0.25. This is counting error. And then again, to get your A inverse V number 1. A inverse V number 1. Okay, to get your A inverse V number 1, then we want to get A inverse V number 1. Okay, you will use back, find back the C. V1 is stored in the max answer. It's stored in max answer. So your option, take back your, C is actually your A inverse, which is number 5, multiply, V1 stored in max answer. So option, max answer, number 1. So you get negative 0.0625, 3333, 1458. So the process is repeated. Okay, so M2 now, the magnitude, the largest magnitude, which is 0.3333. Okay, so repeat the process. Okay, repeat the process now. Repeat the process where your A inverse, this one is your V2 A inverse multiply this one, this is 0 A1. So again it's a C times your max answer. And to get your V2 is A inverse. V2 is a A inverse V1. A inverse V1. Okay, sorry, divided by your MK plus 1, which is M number 2. M2. So you take this one, just divide the largest magnitude, which is 0. So you get your V2. It is 0.4375. Okay, 4375. Here this is a counting error. So 4375. We obtain here. So to get your A inverse B number 1. A inverse B number 1. Here now this one become 1. A inverse B number 1. The process is repeated. Okay. Sorry. Now A inverse B2. In the process of A inverse B2, you always get A inverse is represented using C. BK is represented using your max answer. So you use C times your max answer. So your option, click the matrix number 5, which is C is actually A inverse times your V is stored in max answer. One 8 8333 3177. This is a largest magnitude 0.8333. You get the next V, the next eigenvector take your max answer here, divide by 0.833. C and C. Okay. So you'll get V number 3. The process is actually A inverse V1. This one is stored in max answer. So now this is a only takes your max answer, divide by your divide your MK plus 1. So mean V number 3 will divide by M3. V number 3 divide by M3. So this one max answer divide by 0.8333. 60,999 and then 3812. Let's run a little bit. Okay. So to get the A inverse BK, so we can erase some in general so that you won't confuse. A inverse BK, you use C times your answer. To do A inverse BK, only the first step, A inverse V naught, you use C times your matrix P. Okay, later on, the V1 is stored in max answer. So that's why we always use C max answer. So here I want to do here, so options, number 5 time answer. Okay, and MK plus 1 is the largest magnitude, so correct. To get the next VK plus 1, the next case to get your VK is always your take from your max answer, divide by your MK. So mean V4, so you divide by M4. Okay. So this is your max answer, so divide 1.1333. 278, so it's 3341. So repeat. A inverse BK is takes a C multiply max answer. Okay, negative 1862. And then this is the largest magnitude. So repeat to get the next BK. Use the max answer, divide 1.1863. 2.9455, 8.9999, 8.3224. This little round it. Okay. So to get the A inverse BK, take C multiply max answer. So options, C multiply options. Click your max answer. So you get negative 1.1310. Go down 1928 3783. Okay, so the MK plus 1 is the largest magnitude here. So repeat to get the next VK. Max answer divide 1.1928. You get here 9482. This is a 1. Okay. And then 3171. Put the data on the bit as better. Okay, to get the next A inverse BK is C max answer. So option 5 time option, next answer, okay, this here. So you get 13222, 1936, 377, okay, the largest magnitude here. Okay, so you need to repeat until your mk plus 1 minus mk less than epsilon. This one stay greater epsilon. So we repeat one more time. The next bk is take a max answer, divide, okay, divide this value 1.1936. So 0.948613164. Okay, this one done. A inverse bk is C max answer. Okay, so option matrix C into 5 prime. Okay, matrix B, matrix C time max answer option. Because the B is stored in max answer. You get 1.1324, 1937.3775. This one done. So the mk plus 1 is the largest magnitude, 1.1937. So now you notice, okay, the m8 minus m, but this is mk plus 1. When k is 7 is m8, m8 minus m9, this m8 minus m8 minus m7, okay, their magnitude is 0.001 less than 0.005. Then the largest magnitude eigenvalue for matrix A inverse is lambda inverse is equal to this value, which is m number 8, okay, which is 1.1937. Okay, hence the smallest eigenvalue, which is lambda 3, is approximately equal to 1 over lambda inverse, which is 0.8377. So, and its corresponding eigenvector, okay, V1, which is V8, okay, the corresponding eigenvector, which is the last one. So, B3, plus lambda 3, so B3 approximately equal to V8, which is 1937. Okay, I get here. So this one is stopped at M8. We should find V number 8. So I should get the max answer, divide 1.1937. So you get negative 0.94871, 0.31, 0.3163 transpose, because suppose it's a vector. Then 1 is 0.1667. Why I get 1, but just now why I get this one is not 1, because this one you get 1 over, you press 1 over 6, then this value will get 1. Let me show it back. Okay, so I repeat, repeat. Okay, only first time to get the A inverse B naught, we reduce C times B. Only first time. Because initially 110 is stored in matrix B. Okay. So options number 5 times option E. Okay. So this is 1 over 6. Okay, that's why I in the PDF I get 1, but just now I calculate I get 0.9999 and answer run a little bit, okay, because of in the PDF here I use the fractions rather than 0.1667, okay, rather than 0.1667. Okay, so only first time you use A inverse B naught, you use matrix C, okay, because This is matrix C. This one is stored initially. V naught is stored in E. Okay, and so for MK plus 1 is 0.1667. Okay, to get V number 1, we find the answer a bit different. Okay, so to get this one, we see the answer. If I divide by this one, divide by 1 over 6 is actually times 6. Divide by 1 over 6. And this way you get, now you get very nice 1. Right? So you get here 1. And then, okay, so for the following step of A inverse BK, A inverse BK, okay, A inverse is stored in C. V start from V1 onward is stored in next answer. We use C time next answer. That's why options 5 time option to the find next answer. So against here, okay, divide 1 over 3 is times 3. That's why I can get all here 1. But if you use divide by 0.333 just now as in the previous step, you see all the most of the value here run a little bit because of when we divide here. If I divide by 1 over 6, it will be more accurate than I divide by 0.1667, introduce rounding error. We introduce a rounding error. I'll show you just a few steps. Okay. So now this one, you get it. Okay. So divide by 1 over 3 is actually your time 3. So that's why you get this one point is actually negative 3 over 6. 875. So 1 4 3 7 5 4 3 7 5. So the next A inverse BK is the options 5 time options next answer. So it's actually if you click for display purpose for right in here, I will write in floating point, but in the actual calculation, okay, this one is 5 over 6. 5 over 6. So we divide by 5 over 6. 3177. Okay. The largest magnitude is here. C is here. Show you one more value. So this one is 5 over 6. 5 over 6. Okay. So to get the next B3, the next answer, divide by 5, divide 5, divide 6. So you get 8063 1 3813. So that's why just now I see why the answer seems like got rounding error because of the MK plus 1 here. If you use a fractions, okay, or you use a floating point, you introduce the rounding error. Okay, so conclude back. Okay, to get the smallest eigenvalue, we use the inverse How method. They have the vector V naught to store as a P. Okay, and then you find the A inverse V naught. First time you use C times B. You get the M1, which is the largest magnitude of A inverse V naught. Okay, to find the next V1, okay, will be in the next case, start from V1 onwards, you use the max answer because A inverse V naught is stored in max answer. So you take the max case, this one max answer divide by here. Okay, if you can have a fraction, you divide by a fraction number will be more accurate. Okay, and the next A inverse VK onward, because the V1 stored in max answer, so the next A inverse start from V1, you use a C, which is A inverse, and VK star is the next answer. So you get here, get the largest eigenvalue. You get the next V1, take the next answer, divide by MK plus 1. With the MK plus 1 in fraction number, use fraction number. Okay, and lastly, at the end of the power method, you will get is actually the lambda inverse is actually the dominant, the largest magnitude. Okay, largest magnitude. Means your lambda inverse, okay, your lambda inverse, okay, is a MK plus 1, okay, is a largest magnitude, which is our 1 over lambda, lambda 3. Lambda 3 initially is the smallest. 1 divide the smallest, you get the maximum. Hence, the lambda 3 is actually 1 over MK plus 1. And the eigenvector, corresponding eigenvector is always the last one. If you stop at this is M number 8, so you should find V8. So V8 is the corresponding smallest eigenvector. So with this, thank you for your attention.